What is going on, guys? Welcome back. In today's video we're going to learn how to create custom animations with MoviePy in Python. So let us get right into it. Alright, so we're going to learn how to create our own custom MoviePy animations in this video today, and this is very useful. Even though MoviePy comes with a lot of animations, effects, and transitions out of the box, it doesn't cover everything you need, and oftentimes it doesn't even cover some basic functionality. So for example, MoviePy has a transition effect called slide in and slide out, but the way that this effect works is not exactly what I want to use, so it requires you to transition from one thing to another thing. It gets kind of tricky when you have clips inside of clips. I don't want to go into the details of that in this video today, but you can try playing around with a slide in and slide out animation from MoviePy, and you will see that it doesn't do exactly always what you want it to do. So what I want to do is I want to take a clip and I want to move it around a certain way. Now, if there is no MoviePy function supporting that feature, you can just create your own function and pass it you can pass that function to the setPosition method to then determine the position of your clip dynamically, and you can then create your own slide in animation, your own slide out animation, or even something more complex like a circular animation or whatever you want to do. So this is what we're going to learn about today. Obviously for this video we're going to need MoviePy, so go ahead and install it in your command line, pip install MoviePy, and then what we're going to do is we're going to just say from MoviePy.editor, we're going to import everything. Again, in my videos, when I use wildcard imports, I do it for the simplicity of the tutorial. In an actual project, don't use wildcard imports. Import the actual names that you're using. I'm just going to use this asterisk here because it keeps things simple for the video. We're also going to need NumPy, by the way, so if you don't have NumPy installed, just go pip install NumPy, and then we're going to just import it up here, import NumPy SNP. And now what we're going to do for the first example here, we have a basic video. I just downloaded 2 copyright-free materials from the web here. So I have, first of all, this video here, very simple. I don't know, I just picked the first one that came up, and then I have this icon here, whatever it is, I don't know. It's just some image here. What I'm going to do now is I'm going to move that thing from the upper left corner to the lower right corner in a customized way. So I don't want to use some predefined MoviePy function to do that, which is called slide diagonally or something like that. I'm going to define my own function that will move the image in the way I want it to move. So first of all, what we want to do is I want to import video clip. So I'm going to say video clip equals and then we're going to use video file clip, which is a class from MoviePy.editor. And as a parameter here, I'm going to pass just video.mp4. Then I'm going to also create an image clip, which I'm going to call image clip here. And we're going to load image.png. And the important thing is we're going to set the duration of the image to the same duration or to that of the video clip. So I'm going to say here set underscore duration video clip dot duration. And the good thing about MoviePy is that when you call the set duration function, it returns again the image clip with that property. So it's not like you return the image clip here and then you set the duration and that's just a function. No, this also returns the image clip with the property that it has this duration. So now we have an image clip and a video clip. Now, what you can do here for an animation is, of course, you can call certain effects from the MoviePy package. But you can also use functions. So for example, I can go and say imageclip.setPosition. And this again returns an image clip. So you want to save this into image clip. And this returns a new image clip with that position. But instead of just passing a tuple here of X and Y coordinates, I can also pass a function. And this function will determine dynamically the position of this image clip. So I don't have to say something like 20 and 500 here for X and Y. I can pass a function which depends on a variable or on a input parameter called t, which is the time. And based on that t parameter, I can define some mathematical function or a function in general to determine that position. So the basic idea is I have a function here, my function, whatever it is. This function here takes t as a parameter, and t is nothing but the current position in the video. So if you have a video that's 15 seconds, T would be 0, then 0.6 or something, then 1, then 1.3, and so on. So it jumps in a certain way, but it goes basically from 0 to 15, indicating the second that we're currently at. So T always gives you the current second of the video. And if we have a 15-second clip, T is going to be something between 0 and 15. And you can take that as a parameter to define some movement. So for example, I'm not going to even define this here as a separate function. I'm just going to use, or actually, I'm going to define it as a function because it is just more explicit. You can also define this, of course, as a lambda expression. So if you don't want to define a function, you can just go and say lambda t, and then you can define the position here in a lambda expression. But I like to have it more explicit here for the sake of the tutorial. Probably in a real project, I would use a lambda expression, but here I'm going to just say simple motion depending on t. Again, t is the second that we're currently at, ranging from 0 up until duration of the video. And what we're going to do now is we're going to say, okay, we want to go from the upper left corner down to the bottom right corner. So essentially, we're going to go from 0 up until the video here is, I think, let me just see, open in Explorer. I think the video is 1280 times 720. So we would go from 0 to 1280, and from 0 to 720, so we would go diagonally, but we want to do it gradually depending on the time. So what we're going to do here as a very simple mathematical formula is we need to return here x and y values depending on t. So we get a certain point in time from 0 up until video length, and this point has to be included in a formula that results in x and y. So for example, if I say return, first of all, if I always say return 0, 0, the video will always stay at 0. So I could pass this function here. I could say set position is going to be just, now we're going to pass a lambda expression here, lambda t, calling simple motion t. I'm not sure if we can, I think we should also be able to just pass simple motion. Let me just try that. So simple motion like this. And then we're going to say final clip is going to be a composite video clip, which is going to be the video clip and the image clip. And then we're going to just say final clip dot write video file output simple dot mp4, and the FPS are going to be the FPS of the base video. Let me just make sure I'm not blocking this here with my camera. FPS is going to be video clip dot FPS. So if I run this now, this is hopefully going to start a process. There you go. And it's going to produce this output symbol. Now, our function here always returns 0, 0, no matter what t is. So I can open this now in the Explorer, and this is what we get. The icon or the image is in the upper left corner, constantly not moving at all. So if I say, for example, okay, I'm not going to go with 0, 0, I'm going to go with t times 5 and t times 5. Come on. There you go. This would be some movement depending on t. It's not exactly what we want. I mean, it would move in some way diagonally, but it's not what we're aiming for. But you can see that, or you will see here in a second, that moving this, there you go. You can see there is some movement here depending on t. It's t times 5. And t goes up until 13. I mean, you cannot see that here. Let me just fix this. There you go. You can see the video goes 13 seconds. So t would be a max of 13 times 5. You can calculate that. But this is not what we want. What we want is we want to move from the upper left corner to the lower right corner. How do we do that? Quite simple. We can say here, I want to have t divided by video clip dot duration. Why do we want that? Because this will give us a percentage. The video clip duration is 13 seconds. T goes from 0 to 13. So this expression here, t divided by video clip dot duration, will be something between 0 and 100, or I mean percent, 0 and 100%, or actually 0 and 1. So it will be something between 0 and 1. So it's going to be a fraction. It's going to be either the video hasn't started yet, or the video is finished, or something in between. Based on this percentage here, we want to get the position. So we're going to say this times the maximum width. So it's going to take the percentage of time, and it's going to apply it. It's going to transform it essentially into percentage of width. So if we are 50% through with the video length, we're also going to be 50% through with the movement. That's the basic idea here. And we're going to do the same thing also with the height. So t divided by video clip dot duration times 720. That is a simple movement. So let me run this here, and this should produce the result that we want to see. It's going to again be in that file. So Explorer, there you go. Now I can see how it moves from the upper left corner to the lower right. Now we're almost halfway through the video. Now we're in the center. There you go. And boom. Now the reason you might be saying, okay, it's not moving exactly. It is actually moving exactly into the middle and exactly into the lower right corner. But what we're actually moving is the upper left corner of the icon. So we're not moving the center of the icon, which is why it seems it's a little bit shifted to the bottom right. It is actually moving exactly from the upper left corner to the lower right corner, but it's moving the upper left corner of this whole thing. So when you set something to position 0, 0, it's not setting the center to 0, 0. It's setting this upper left corner to 0, 0. Yeah. So this is a very simple one. Let's go for a more complex one. Let's try to have a circular motion. So what we want to achieve here is we want to have the canvas. So we're going to have something like this. It's not the most beautiful canvas that you have seen. It's again 1280 times 720. And we want to have our icon or logo, whatever it is, in the middle. And we want to then, or actually we don't want to have it in the middle. We want to have it rotating around the middle. So if this is the center point here of the whole canvas, or of the whole screen, we want our icon to start here, and we want it to move around evenly one time around the center. Now, this is not very accurate here. This is even less accurate. With the mouse, it's a little bit hard to write something. Okay, yeah. It should be a perfect circle here around the center with a certain radius, r, which is the same everywhere. So it should be symmetrical. So in one video length, we want this icon to go full circle once. That's the basic idea. And what we're going to need for that is a simple mathematical formula. This center here is going to be just the screen width and the screen, or actually the video width and the video height divided by 2. Again, this would mean here that we're going to take this upper left corner. Now, to not center this upper left corner, we're going to again subtract, or we're going to add, no, we're going to subtract the image size divided by 2. So the width and the height, so that we end up here, if you do this properly, here in the center. So this is going to be here then. And then we're going to rotate this using the sine and cosine, because essentially, now this is a little bit of trigonometry, one full circle rotation would be 2 pi. So here you would have 0, here you would have, here you would have pi, here you would have pi divided by 2. Here you would have 2 pi, and down here you would have then 3 pi halves, like this. And to get the x coordinate, you would get the cosine of whatever the current angle is, and to get the y position, you would get the sine of whatever the angle is right now. So this is just if you want to understand the theory behind rotating the circle. Now we can take this and implement it into MoviePy by saying the following. The center on the x-axis is going to be the video clip size dot size index 0 to get the x-coordinate, and we're going to divide this by 2. From this, we're going to subtract now the image clip size index 0 divided by 2. And we're going to copy that whole thing for index 1 to get the y-coordinate center. We're going to call this center y. This is now just the center of the screen, adjusted also for our icon size or image size. Then we're going to define a radius. Let's go with 200, for example. 200 meaning how far are we going to go out? Because of course, if you have a radius of 1, you might rotate like this. If you have a radius of 5,000, you might rotate something like this. I mean, way more than that. But that's the basic idea of the radius. So how much do you want to go out from the center? And then we're going to now say not simple motion, but circular circular motion. Not circle position, circular motion, which is a function depending on t. And here now we're going to apply a simple principle. This is the same simple principle. We're going to say here that the position x is going to be the center position plus the radius, so how far away from the center are we going to go, and in which direction are we going to go. So plus radius times np from numpy cosine to get the x coordinate. Remember, we have this graph here. The x coordinate is the cosine, the y coordinate is the sine. Cosine of what? Of the current position, which is going to be again t divided by video clip dot duration to get the ratio of how far in the video we are, times, okay, so basically what we want to say now is, okay, we have the percentage, how much of the video have we seen. We want to transform this into how much of the circle have we already traveled. Remember, the full circle is 2 pi. The full circle rotation would be 2 pi. So if we are 50% through with the video, we would want to be at pi. If we are 1/4, so if we are 25% through the video, we would want to be here. So essentially, we just take this ratio times 2 times math.pi. And we need, of course, to also import math. And then this is the x axis now, and for the y axis we do the same thing. For the y position, center y plus radius times np sine to get now the y coordinate. Same ratio, t divided by video clip dot duration times 2 times math dot py. That is it. Now, before I explain once more what is happening, let me see if that actually works. So we're going to run this, and then it's going to output, again, actually simple. We should rename this to output circular. But let's see. There you go. You can see this rotation here happening around the center. And this is exactly what we want. Now, if we increase the radius, so if we increase the radius to 400, probably we're not going to see much of the image, but it's going to go faster because it has to go. The circumference is, what is the formula for the circumference? I think it's 2r pi, if I'm not mistaken, because the area is r pi squared, or r squared times pi, I think. So 2r pi should be the circumference, and if the radius is 400, this means you have just more circumference to go through, so it's going to go faster. Oh, actually, now I'm creating the video again. Let's see if that works. There you go. So now we have 400 and it goes a little bit faster. What we can also adjust is we can adjust how many rotations we want to have. If you say the percentage is from 2 pi, it's going to go 1 rotation in 1 video length. If I say it's 4 pi, it's going to go 2 rotations per 1 video length. So if I run this here with 4 pi, this now means that the standard is not going through the circle once, it's going 2 pi and then 2 pi again. So 4 pi. So the percentage would be at 50%, you would want to go full circle. So 50% would mean 2 pi and 100% would mean 4 pi. That's the basic idea. And here, if we run this now, you can see that the rotation is way faster. It goes full circle here twice. So yeah, and you can be creative with that. Let me maybe one more time explain this if you were not able to follow that easily. Basic idea is you have a center. We determine the center by dividing video clip size by 2 and the image clip size by 2 to also center the image, to not be in the upper left corner of the image. And then a rotation is defined as take the center and go to a certain direction. The direction is depending on how far we are in the video, which is indicated by t. If 1 full circle rotation is to be done in 1 video, 1 full circle rotation would mean t reaches the video duration. I'm going to call this dur here. So 1 full video duration means 1 full circle rotation. Thus, when you have 50% of the video seen, you're going to be at 50% of the circle, and the position is defined by cosine and sine. Now, if you don't understand this at all, you don't need to understand this. This is just trigonometry. You can also just use something that doesn't involve trigonometry and rotation, so you don't have to use cosine and sine. The one thing that you need to learn in this video, or that you need to takeaway from this video is that you can create functions depending on t, and those functions allow you to dynamically or manually configure movements. So you can just say set position depending on this particular time. So you have a time t, and depending on that, you can create some formula that defines movement. So that's it for today's video. I hope you enjoyed it and I hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.